Okay, so you also should know the periodicity, and I actually talked about that. Sine and cosine are what we call 2 pi periodic. They repeat every 2 pi. So for n any integer, theta plus 2 pi later, or theta plus 4 pi later, or theta plus 6 pi later, etc. The sine is going to be the same. Same with cosine. Tangent is what's called pi periodic, so it repeats every pi units, not every 2 pi. So for example, let's say you were told that the sine of t is equal to something, the cosine of t is equal to something, and the tangent of t is equal to something, a, b, and c respectively. So could you figure out what the tangent of t plus pi is? Certainly. Tangent of t plus pi is the same as the tangent of t, because tangent is pi periodic, so pi units later it's back to the same guy. And the cosine of t plus 2 pi, well, that's the same as the cosine of t, because 2 pi units later the cosine is the same. The sine of t plus 4 pi is also the sine of t, because 4 pi, remember it's 2 pi periodic, so 2 pi later, 4 pi later, 6 pi. So 4 pi later, the sine is the same, so it's back to sine of t. So then you know those guys, right? Tangent of t is c, cosine of t is b, so it's c minus b. Sine of t is a, so plus a. C minus b plus a. All right, example 3. Let's say the height h in feet of water at a boat dock t hours after 6 a.m. is h equals 8 minus 3 times the sine of pi t over 6. Find the height of the water at the dock at 9 p.m. So how many hours after 6 a.m. is 9 p.m.? Well, 6 p.m. would be 12 hours. 3 hours more would be 15. So the height then would be 8 minus 3 times the sine of pi over 6 times 15. So 15 pi over 6. So again, I want to figure out a coterminal angle that's between 0 and 2 pi, because that's what I work with on the unit circle. So 15 pi over 6 is what? That's 2 and 3, 6 pi. So that's 2.5 pi. So 2 pi would be all the way around 2 pi, and then another half pi would be up here at the 90-degree mark. So pi over 2 is the same as 15 pi over 6. All right? So in other words, sine of 15 pi over 6 is the same as sine of pi over 2, which we know is 1 from our unit circle. So this is 8 minus 3, or 5 feet. Example 4. Let's say we know that we're at the point 3/5 minus 4/5, and that's a point on the unit circle corresponding to some real number t, in other words, an angle. Sometimes the author likes to use t's instead of thetas, or even x's instead of thetas, but it just means the angle t or the angle theta. Don't worry about whether the variable name is used. Okay, so the point 3/5 minus 4/5, we want to find the values of all the trig functions at that t. So 3/5 minus 4/5. Well, I know I'm down here in this fourth quadrant, right? Because the x value is positive and the y coordinate is negative. So I'm down here, and I'm just going to draw the point, label it 3/5 minus 4/5. So the angle t I'm looking for is that guy. The positive angle t is this guy. Well, in actuality, these are nice. I don't need to know exactly what that angle is. I just need to know what the cosine and the cosecant and the tangent and the secant and the cotangent of that angle is. So here's my angle t, which I don't need to know the exact angle. Now I know that the cosine, or excuse me, let's start with, so sine of t would be opposite over hypotenuse. Now that would make this 4 over 5, but I know that has to be minus 4 because it's on the negative y-axis. Remember, here's t, so our reference angle is this little guy in here. So the sine of that would be opposite of my reference angle over the hypotenuse. Opposite over hypotenuse. So I would label that minus 4 over 5. Cosine of the angle t is adjacent over hypotenuse of my reference angle. So that's 3 over 5. And then I remember that sine of t has a relationship with cosecant t. In fact, cosecant t is 1 over sine t. So that would make cosecant t minus 5/4. Secant t is 1 over cosine t, so that would make secant t 5/3. And then tangent t, I have to go back to my reference triangle and realize that tangent is opposite over adjacent. So minus 4 over 3, or minus 4/3. And then cotangent of t is 1 over tangent of t, so that's minus 3/4. Okay. The last thing to really talk about in this section is what's called the Pythagorean identities. So sine squared of theta plus cosine squared of theta equals 1. That's a very famous identity. I mean, that comes from the unit circle, right? If we have the equation of a unit circle is x squared plus y squared equals 1. So remember, the x's are the cosines, the y's are the sines. So x squared is cosine squared, y squared is sine squared, so x squared plus y squared equals 1. Well, in terms of trig, that's the same thing as saying cosine squared theta plus sine squared theta equals 1. And then you have these other ones which are really reduced from these guys, because notice that sine squared theta over cosine squared theta, well, tangent of theta is also actually defined as sine of theta over cosine theta. So this would be tangent squared theta. Cosine squared theta over cosine squared theta is 1. So tangent squared theta plus 1 equals 1 over cosine squared, which would be secant squared. Bottom line is it comes from this guy. Or if I divide everything by sine squared, I'd get 1 plus cosine squared over sine squared theta is the same as cotangent squared theta. And then 1 over sine squared is the same as cosecant squared theta. So either of these are called the Pythagorean identity. If somebody just says, hey, use the Pythagorean identity, they actually mean sine squared theta plus cosine squared theta equals 1. Okay, so as a fifth example in this section, we have theta is an acute angle, means less than 90 degrees, and cosine of theta is square root of 31 divided by 9. So use the Pythagorean identity, sine squared of theta plus cosine squared of theta equals 1, to find sine of theta. So I know theta is this less than 90 degree angle. Since sine squared theta plus cosine squared theta equals 1, that tells me sine squared theta equals 1 minus cosine squared theta, which tells me that sine of theta, take the square root of both sides. Now technically I probably should put plus or minus, but not really, because I know sine is positive over here in this first quadrant. So sine of theta is the square root, because it's the positive square root, of 1 minus cosine squared theta. So I plug in cosine squared theta. So I square both terms here. I get 31 over 81. So 1 minus 31 over 81 would be 50 over 81. Square root of 81 is 9, so I'm just going to put that. Square root of 50, well, that's the same thing as 25 times 2. So that would be a square root of 25, which is 5 times the square root of 2. So the final answer is 5 square root of 2 divided by 9. And as the last example, let's use an identity to find the value of cosecant squared of pi over 5 minus a cotangent squared of pi over 5. So if you go up to your Pythagorean identities, you'll notice that cosecant squared of pi over 5 is the same as 1 plus cotangent squared of pi over 5, because cosecant squared of theta is 1 plus cotangent squared of theta. So our theta here is pi over 5. So notice that the plus cotangent squared of pi over 5 minus cotangent squared of pi over 5 cancel, and I get that this equals 1.